Good morning or good afternoon, whatever it is. I just had a major computer catastrophe and I almost had a heart attack, but I'm pretty sure I fixed it. So, oh, thank goodness it had nothing to do with your class, but it was a little traumatic. I think it's fixed, but we'll see. Just 27 assignments got deleted from my online class. Yeah, is that terrifying? Yeah, but I restored them. I hope I sent an email out to all of them that are like, I hope I fixed it. I don't know what is happening, but it's exciting. It's not exciting. It's very terrifying. So somebody chatted something to me. Yes, Vanessa, go ahead and leave your camera off. Jessica's asking about the Flipgrid. Hold on, since my little assignment trauma, I'm not even sure what the assignment is. So I'm gonna look at it right now.
What is Jessica? Oh, okay, yeah. Yeah, I also have a question. Yeah, I have a question in regards to that too.
Okay,
If like
let's talk about that when everybody gets here too. Make sure,
Okay.
because if you both have questions, I'm sure you're not the only one. And then you have your division assignment from yesterday still, right? The second page, we're gonna start there. That's fine, Karen, no worries. Were you guys able to, those of you that were struggling yesterday, were you able to go through that, those problems? There were, what, three, well, maybe four, 3 or 4 that you guys were struggling with. Were you able to make sense of them? Nobody responded, so I guess you're fine or terrible, something. One or the other. All right, I think most of us are here. There's a few that are missing. So the first thing I wanted to talk about was a couple people have questions about the flip assignment. Okay, the biking to Bernie's flip grid. So Tika, what's your question?
I'm confused on how to like go on with my strategy because I tried 2 different ways and I'm just struggling how to like continue it. So I tried the drawing picture method of like doing like a number line where it's like Bernie's house, say in the middle was Beth and Billy, but I didn't know how to continue that. So then I tried an equation. That didn't help either. So I'm just lost on how to like continue from starting the strategy. If that makes any sense.
I'm not going to solve the problem for you.
Well, I'm not asking that. I'm just like,
so
I'm just lost.
A number line is a great strategy.
Okay.
A number line is a great strategy. So you could say parts of the trip versus miles, right? So, and then Vanessa, I think you had a question about it too, and maybe this will help with Jessica's question too.
It was kind of the same question Jessica had. So I guess, yeah, that answered my question.
Okay, and you can use the 4-step method. You know, what do I know? What am I trying to find out? What's a guess that's too low, too high? And for me, number lines is the best for that problem in particular. But you do have to pay special attention to your units. Okay, what are your units? Which is kind of the whole theme of fractions for us, right? Anyone else who already did the flip grid assignment, like even if you just solved the solution, you didn't post your video yet, any helpful hints without giving them the answer for Vanessa or Jessica?
I mean, you said it, the number line is super helpful. If you can really understand the problem, make sure you know all the givens, then the number line should work pretty well.
Yeah, I think the number line's the way to go.
I think the biggest thing that helped me was relating it to, don't look at it as just a math problem, because like my biggest problem, especially when I'm solving these, is that it may be a real world experience, but in my mind, I'm trying to solve it in like I'm in school experience. Take it and actually use it as a real world experience, as if you're trying to solve like how long it would take you to get to a certain place yourself. Replace yourself in the shoes of the 2 people. And that helped me a lot to kind of describe it and solve it.
Nice. That's great help, Tyler, especially because, you know, doing an equation, you're trying to fit a practical situation into a contrived equation that might not make sense to you. So, you know, just make the problem make sense to you, and I'm pretty sure you'll figure it out, you know, without like a formal equation or something. A lot of people get stuck on that. Okay, think about it, Jessica and Vanessa and everybody else, but if you're still stuck, come visit me tonight in office hours and I'll see what you have done so far and we'll go from there. Does that sound good? Okay.
Sounds good. Thank you.
Okay. Okay. I know lots of people are having unstable internets and whatever. You guys weren't here when I first logged on, but I had this terrified look on my face. I had a major computer disaster right before class. It didn't affect you guys at all, which was good. But my one of my other classes, 27 of their assignments got deleted. Yeah, you heard me right, deleted. Thanks for that face. I appreciate that. But I was able to restore them all, I think. So that was lovely. So I'm a little recovering still from my trauma. So that's exciting. And I had to give a test in my other 2 classes, and they were using Respondus Lockdown browser, and it was like chaos town. So yeah, it was crazy. So cross our fingers, everything's okay, and we're good to go. But what I want to do with us first is I want to finish up that division thing before we start with proportional reasoning, because division, and I'll answer any questions you have about multiplying fractions as well, because if you notice, today and tomorrow we're doing proportional reasoning. So I don't want to have pushed too fast with multiplying and dividing fractions and have left you in the dust. because that would be a bad thing, because multiplying and dividing fractions is super, super important. Not that proportional reasoning isn't, but I already had 2 days reserved for it, so we're good to go. So let's recap yesterday with the Cuisenaire rods. Some of you are like, no, I don't want to recap yesterday with the Cuisenaire rods. That sounds like a terrible idea. I want to pretend they never existed. Some of you, I'm guessing, took some time yesterday to kind of process it for yourself after class. Am I right? Is there anyone who was able to go through those and make more sense of them? Nobody.
Well, it kind of helped me with like the visual handout that we did. Was it Monday? It kind of helped me understand that a little better too.
Good, good. This is all about, you know, the units and what am I copying. So on those 4 problems at the bottom were the most troubling, right? And I think Hannah and Tyler did you guys do, yes, you did the 3rd one down. How many copies of 1 1/2 are in 1 2/3? And then we did together, how many copies of 4/9 are in 2/3? How about either of the last 2? Is there any brave soul that wants to try to explain it? You can talk me through it, or would you like me to do either one of those, just to kind of recap yesterday?
The last one, 1/2 divided by 1 1/2, that one seems a little tricky because it's more going into less.
Okay, so 1/2 divided by 1 1/2. So it's asking you how many copies of 1 1/2 are in 1/2. So first I'm going to show 1/2. We all agree that a blue is 1/2. Yes?
You weren't sharing your screen. Yeah.
Dang it, dang it. Thank goodness you told me right now. Someday I'll get really better at that, and that'll be when we go back face to face. No, I doubt it. We'll be back face to face, and I'll still be thinking I'm sharing my screen, and I won't be. Craziness. Okay. It's not even what I wanted to share. There we go. So a blue, now you can see it, yes? A blue is 1/2. Do we all agree? All right, good. So then we want to know how many copies of 1 1/2 are in 1/2. Well, how do you want to show 1 1/2? I think this was Alyssa, right? Alyssa asked for this one. How do you want to show 1 1/2?
It's 1 1/2, right?
Yeah, so how do you want to show that with your blocks?
So you can do the orange and the brown for 1. And then the half
Okay.
would be a blue.
Okay, so there is, this top line is 1 1/2, right? I'm going to actually move it down here.
Yeah.
So now the bottom line is 1 1/2. The top line is 1/2. Yes?
Yes.
And I'm asking for how many copies of this bottom piece are in this top piece. Now, do you agree that there's not even 1 copy?
Yep.
Yeah, because what we're trying to fit in is smaller than what we're copying. Yeah, so I have to figure out how big this copy is compared to what I'm dividing into, or my dividend, which is 1/2. So any ideas on what I should do next? Well, I could do this. Do we all agree that 3 blues are equivalent to that bottom line now?
Yes.
Yeah, and that is true. So, so I can't even make 1 copy. So what part of 1 copy do I need to make this 1 blue?
1/3.
Aha, you're right. You need 1/3 of a copy to make that one blue. Yeah? You need 1/3 of a copy to make that one blue.
Is she saying 1/3 because there's 3 of them and you had
Yep.
1/4? Okay, just want to make sure.
Yep. So if the question was different, if I asked how many copies of 1/2 are in 1 1/2, then what would my answer be? How many copies of 1/2 are in 1 1/2?
3.
3. So when I reversed that division, saying how many copies of 1 1/2 are in 1/2, did you notice your answer is the reciprocal? It's 1/3.
I guess it doesn't click in my brain like that because you're adding to it, and I'm just like, were you just pulling these numbers out to add to it? But then when you say it 1/3 instead of saying 1 1/2, that makes more sense. It's very tricky.
Yeah, it is tricky. And what's funny is with your algorithm, you'll get the right answer, right?
Yeah, but that's a little harder.
It is harder. I agree. Well, I don't know. This bends our brains though. So look at the one that was the one right above it. What is 1/9 divided by 1/3? In other words, how many copies of 1/3 are in 1/9? Well, what was 1/3? Wasn't it the dark green? Yeah, the dark green was 1/3.
Yes.
So how many copies of this dark green are in this red? Again, not even one copy, right? Not even one copy. Because I'm trying to fit the green into the red. So now I have to have parts of a copy. So what is my answer on that one?
3.
Be careful.
1/3.
It's 1/3. Yep, our brain wants it to be the other way, but it really is 1/3. Okay, did that help you kind of process that a little bit? Okay, practice those. Now, if you flip it to the new page, it says, what is 6 red rods? And we started this at the very end of yesterday. Okay, so what is 6 red rods divided by 2 red rods? So in other words, how many copies of 2 red rods are there in 6 red rods? Well, I think you can see it, right?
3.
You can see there's 3 copies, right? Yeah. Okay, so our answer was 3 on that one. Now, the next one down says, okay, what if I have 6 white? Oh, that's 7. And I'm dividing it by 2 white. How many copies of 2 white are in 6 white?
3.
3. That wasn't too confusing. And then what about purples? What if I have 6 purples? Oh, it didn't want to fit there. 1, 2, 3, 4, 5, 6. And I'm dividing it by 2 purple.
3.
Yeah, 3. You're like, okay, I get that part. Now, so the question on part D says, did it matter what color rods was used to solve 6 divided by 2? No, it didn't. Why not? Why did it not matter?
Because they're all the same color.
Because they're the same color. It would have been different if I would have said, I have 6 dark greens. Of course, I picked one that doesn't fit. And I'm dividing it by purples. That's a different question, right? That doesn't make as much sense. When they're different colors, it's more challenging, right? So when we're talking colors, do you remember when we did the pattern blocks? We referred to the color as part of the fraction. Which part of the fraction was it? Was it the numerator of our fraction or the denominator of
I
our
thought it was
fraction?
the denominator, wasn't it?
It was the denominator. So if that applies here, we would say, as long as we had the same denominator, it didn't matter, right? We could ignore the denominator and just say, okay, it's 6 divided by 3. Interesting idea. Okay, so that being said, let's look at that bottom table. And I'm just going to write right here on this blank space. You have a problem that, oh, maybe I even have this. Hold on, I bet I have this worksheet. I thought I did. If I labeled things, it would be very helpful. Do I have this worksheet labeled here somewhere? Oh, there we go. Okay. So here's the beginning of it. I just wanted to see why that was there. Okay. So the original problem, 1 divided by 1/2. We might use different colored rods for that. But since we just learned if we had the same colored rods, which would mean the same denominator, it's much, much easier. So we're going to rewrite this 1 with a denominator of 2. Do you all agree that 2 over 2 is equivalent to 1? We're okay with that. Okay, so we're going to do 2 over 2 divided by 1 over 2. So if you were thinking of a picture, not necessarily with Cuisenaire rods, just a picture. If you have one hole and it's asking how many copies of 1/2 are in one hole, you would say, oh, there's 2 copies of 1/2 in one hole, right? That would make sense to you. Now, since we just figured out, as long as our rods are the same color or our denominators are the same, we can just say, ignore the denominators and just divide the numerators. So 2 divided by 1 is the same as 2 over 1, which is the same as 2. Sound good? You might not quite believe it yet, but you can follow directions, so you're okay, right? So if I want to get a common denominator between 3 and 9, what's the common denominator?
9.
9. So let's rewrite that first fraction. So 2/3 is the same as how many ninths?
6/9.
There you go, 6/9. So now we have 6/9 divided by 1/9. Now, if we originally had 2/3, so here's our hole. I should make it the same size as the one above it. Here's our hole, our unit, and we have 2/3. So we have all this. And I want to know how many copies of 1/9 are in 2/3, right? How many copies of 1/9 are in 2/3? Well, if I split this into ninths, I would draw lines there, right? If I would split each one of my thirds into thirds, then I would have ninths. Do you agree? And then you can see I really have 1, 2, 3, 4, 5, 6 copies of 1/9. Yeah? I have 6 copies of 1/9. So since I have the same denominator, I can just ignore the denominator and do 6 divided by 1, which is 6. And that's our answer. You like it? Maybe. Maybe you don't. Try the next one. You don't have to draw the picture. You can if you want, but just try the next one. Get a common denominator and tell me what your answer is. After you're done, get it ready in the chat and don't hit enter yet. All right, does everybody have their answer ready? I see a couple people still working. I'm gonna give you about 30 more seconds. All right, does everybody have an answer? Type it in the chat. 3, 2, 1, go. So I have some of the same answers, but not all of the same answers, right? So let's take a look at that one. You changed the denominator to 9. So you got 1/9 divided by 3/9. Yes? What the picture would look like is I have 1/9. Let me split that into 9. Okay. And I'm looking for how many copies of 1/3 are in 1/9. Well, this is 1/9. But this is 1/3. So I can't even fit one copy in, right? I can only fit part of a copy in. And remember, when you have the same denominator or the same color rod, we figured out that we could just ignore the denominator and say, oh, that's 1 divided by 3, which is 1/3. Yeah, probably none of you were ever taught to get a common denominator when you were dividing fractions, right? Nobody was ever taught that. Am I right? Yeah. Can I? Yeah, I can. It's fine. Let's look at it on this one with mixed numbers. Now, with mixed numbers, we still need to deal with it somehow. So it's easiest if we make them improper first. So let's make them improper first. So this would be 5/3 divided by 3/2. Do you agree with my math there? Okay. Now let's get a common denominator. What's our common denominator between 3 and 2? 6. All right, so let's rewrite this with 6's as our denominator. And I didn't draw a picture on this one because this is when it gets a little messier to draw. We could, but it just gets a lot messier. Now, does everybody agree with my 10/6 divided by 9/6? All right, so once I have the common denominator, what can I do? What can I do?
You could flip the 9/6.
I'm not flipping anything. Did I flip anything on this whole page? Did I flip anything over? Nope, I did not flip anything over. Nothing did I flip over. I didn't need to. I can just ignore my denominators because it's like saying 10 red rods divided by 9 red rods or 10 white rods divided by 9 white rods, right? So I can just do 10 divided by 9. And 10 over 9 is the same as 1 1/9. Do you agree? Flip back to the page before or look at your previous page. These problems should seem familiar. We did them differently. Did we get the same answers? What's funny is you guys didn't even notice they were the same problems, some of you. You were like, what? They're the same problems? Yeah, they are the same problems, just looking at them in a different way. So questions on that ignoring the denominator part, that makes people uncomfortable.
I mean, it seems kind of similar to like when we're talking about canceling out, how that wasn't really cool because sometimes it equals 0 and sometimes it equals 1, and we just coined the term cancel. But I don't know. It does make sense after doing the whole activity with the rods. So
Yeah, so this is what I want to do now. Do you notice you have 3 blanks there? Yeah, I'll fill in one of them. Okay, I'll fill in one of the blanks. On one of the blanks, make your next problem. I'll write it over here. Sorry about that. I'll write it right here. 2/5 divided by 3/4. 2/5 divided by 3/4. Use the same strategy. Okay. And then you make up 2 other problems. Now, it might be wise to make up fairly simple-ish problems, right? I wouldn't use mixed numbers. I would use just fractions, proper fractions, because it'll make your life easier. And if you want some recommendations, let me know, because I can give you some. But try right now to just work on 3 of those problems, fill in the rest of your chart. You don't have to draw any pictures. Notice that's grayed out on your paper. And then come up with your quotient. And then we're going to talk in just a minute. And if you're having trouble thinking of some of yours when you get past the first one, let me know and I can give you some suggestions. When you're done, type to me in the chat that you're done. Those of you that are not done, are you still thinking? Do you need some problems? What can I do? All right, I'll share mine first, right? My first problem, I had 2/5 divided by 3/4. So my common denominator is going to be 20. And so I'm going to say, oh, that's 8/20 and 15/20. So when I have the same denominator, I'm just going to ignore the denominator because that means the same color, and the color doesn't matter. So I do 8 divided by 15. So my answer is 8/15. Okay, so that's my example. Someone else give me one of their examples. It can be anyone, even if you're like, I don't even know if my example's right. That's okay. I'm not worried about it. Let's fix it here. So anyone have an example?
I can go.
I'm ready, Amanda.
Okay, so I did 7/9 divided by 2/3. And so the common denominator with them was 9. So then I had 7/9 divided by 6/9. And then I ignored the denominator. So I have 7 divided by 6, which is 7/6, which is also a mixed number of 1 and 1/6.
Very nice. Anyone else give me an example?
I can go.
I'm ready, Madison.
So I did 1/2 divided by 3/10. And so then I made it the same denominator by multiplying 1/2 by 5, both the numerator and denominator. So then I got 5/10 divided by 3/10. And then for the equivalent division problem, I did 5 divided by 3. And the quotient, I did 5 divided by 3 is equal to 1 2/3.
Very nice. Is there anyone out there who did one where the common denominator wasn't either of the denominators? You see what I mean? Like with mine, do you notice mine 5 and 4 had no common factors? Did anyone do one like that where they had to come up with a new denominator? Like, you know, with 2 and 3, we had to come up with 6. Anyone do one like that? Brianna, what was yours?
I did 3/4 divided by 5/6.
Very nice. And then your common denominator?
24.
Oh, you used 24. Is there a smaller one?
12.
Yeah, there's a smaller one of 12. I'm just going to use 12. Not that 24 is wrong, but I just want you to see something. Okay. So I bet your answer's still right. Brianna, I just want to show you something. So if we use 12, we're going to get 9/12 divided by 10/12, right?
Yeah.
Okay, so we're going to get 9 divided by 10. And so was your answer simplified 9/10? What was your answer?
Yeah.
Okay,
18/20.
Good, 18/20, which is still 9/10. Okay, now the reason I said, ooh, I'd really like you to look at these. I'm going to show you a couple of them. Remember my first one was 2/5 divided by 3/4. And so I got 8/20 divided by 15/20. And so my answer was 8 divided by 15, which was 8/15. Then look at this one, 5/6 divided by 3/7. My common denominator is 42. So 35/42 divided by 18/42. 35 divided by 18 is 35 over 18. I could simplify that if I want, but I don't feel like it. So we're going to not simplify it. I could rewrite it as a number. So the last one I want to show you is 3 over 4 divided by 1 over 9, which would be 27 over 36 divided by 4 over 36. 27 divided by 4, or 27 over 4. So just take a look at the examples that I just wrote and see if you see a connection between this first column and this last column. Skip the middle. Do you see a connection between that first column and that last column?
If you cross multiply, you'd get the answer.
What do you mean, Tristan?
So like on the first one, if you were to cross multiply, you'd have 2 times 4, which would be the 8 in the numerator, and then 5 times 3, which would be the 15 in the denominator.
Interesting. Yes? Does it work with all of them? Yeah. So do you notice here that 6 times 3 is 18? And 5 times 7 is 35? And 3 times 9 is 27? And 4 times 1 is 4. So I could skip this whole middle step if I just cross multiplied. Or do any of you have a traditional algorithm for dividing fractions that your rule is not cross multiplication? What is your rule? Bethel, how do you do it traditionally? Like, how are you taught to do a division of fractions problem?
You would do the reciprocal of the second fraction when you're dividing.
Okay. So if you had this first one, 2/5 divided by 3/4, you would keep the 2/5 the same. You would change the division to multiplication, and you'd find the reciprocal or flip over that second fraction. What is that doing?
Multiplying by the reciprocal.
And isn't it cross multiplying? Isn't it doing the exact same thing? Yeah, so once again, you were taught a shortcut. Yes, and you were never, ever, ever taught the long way home. The reason this algorithm works is because if we got a common denominator, the size of the pieces don't matter. And we can just divide our numerators. Weird? Isn't that strange that we never made this connection? Now, how many of you, your traditional algorithm is this? And maybe you even say something that makes me cringe. Keep, change, flip. Yeah, some of you learned that. That makes my skin crawl because there's no understanding there. It's just memorization, right? Is anyone's traditional algorithm to cross multiply? Was anyone taught that? Yeah, there's some of you out there. I'm not a huge fan of that. The reason I'm not a huge fan of that is because kids can't remember which one goes in the numerator and which one goes in the denominator. They just guess, and sometimes they're right and sometimes they're wrong, right? So you have to be real careful. Now, do I force students to get a common denominator in order to get the answer? No, but I work with pattern blocks and Cuisenaire rods and things like that to lead them to see that, oh, I can do division in different ways. I've taught people this before, adults, this common denominator method, and some people stay there. right? They like it. It makes sense in their heads. Now, I want you to look at this. If we took this problem right here, 8/20 divided by 15/20, and applied your traditional algorithm, yes? We keep this one, we change to multiplication, and we flip over the second one. What do you notice happens every single time?
You would just cross out the 20.
I
So
love how
it
you
would
guys
just,
are so careful. You're like, I'm not going to say that C word that she hates. So those will always simplify because those will always be the same factor. 20/20 will always simplify to 1. That's because it's the same denominator. It's the same color rods. That's why the color of rod is irrelevant. Yeah, because it'll happen every single time. Yeah? Tricky? But yeah, McKenna.
So is there a method that you prefer over the other? Just because like with the one we just did on the worksheet, it just bugs me a little bit that some of them we can't illustrate with the model, because I started doing it on the ones that were shaded out and they did get pretty messy. So I don't know, I guess I like to use a method that's consistent. So what do you think when it comes to like problems like the ones you shaded out? What should we do with that? Because I like to use the model.
Yeah, so if you're going to teach it, I would choose ones that are easy to model, right, when you're teaching it. And then you might stay there for several days, right, maybe even a week. And then when you discover something, like when you discover, oh, I could just make them the same, right, and get this, then you can say, okay, so we have a rule now. So when we do more complicated problems, we don't have to draw the picture, because drawing the picture becomes very tedious, right? Just like it did with base 10 blocks. Do you remember? With base 10 blocks and whole numbers, we're like, seriously, we have to cross all these out again. So students understand that when we first are showing a model, we might take perfect problems or something that works out a little bit nicer, and then we transform it to an algorithm, which is why why algebra was created, right? Algebra was created for those hard scenarios that we can't model. So we made algebra so we could model those difficult scenarios. So that's what I would do. But I always start with something very concrete. I'm just like you, McKenna. I would start with blocks of some kind. If you like pattern blocks, if you like circles, if you like rectangle drawings, whatever you like the best. And then I would lead to drawings. Drawings would be the next step, because drawings are more abstract than the concrete blocks, just like we did with base 10, and then we moved to our drawings of base 10 blocks. And then you move away. The furthest step is when they abstract and they use symbols and numbers. Does that help?
Thank you.
Yep. Because you can't do every scenario with any of the manipulatives, right? Because there's always some confinement. We only have a certain number of colors of blocks, right? We only have a certain number of pattern blocks. And that's why you keep seeing the same numbers over and over and over again in elementary school, right? Okay, how are you feeling about this? I'm gonna recommend that when you do some problems, especially in like your fraction operations homework or whatever you're working on, if you have some division ones, try getting a common denominator, right? Do it by hand. I'm hoping you're doing it by hand. I know that you have these tools that can even do fractions, but that's not helping your understanding, right? You can check it on these tools, but try these problems by hand and see, especially with these new techniques, just like you did with addition and subtraction and multiplication and division of whole numbers, because it'll help you in your conceptual understanding. Nice. Okay, good. Now, since if you were here both yesterday and today, you just finished your division problems, right? So you don't have to upload them. I'll give you credit for that assignment. If you want to upload them, you can, like, if you're like, I'm not sure I really made up problems that make sense, I'll totally look at it, but you don't have to. If you were absent either yesterday or today, you need to submit this completed. Yes?
So did we have to submit the visual handout then, or was that the one that we did Monday that was due today as well,
Yeah,
or
'cause
no?
we didn't finish that one in class. The visualizing
Oh,
fractions with pattern blocks, you have
yeah.
to do that one. Yes.
Okay, so the division one that we did with the rods yesterday and today, we don't have to submit that one.
Nope.
Okay.
But you can if you want, right? And so notice I already gave you credit for the Jamboard one, right? So I gave you credit for the Jamboard one. Now you'll get credit for the division one unless you were absent. If you were absent, you won't get credit unless you turn it in. Okay?
The pattern blocks one that's due tonight, we started this in class?
Yeah, it was in my slides. I have the first two done on both of them.
Okay.
Completed. So just refer to my slides. So you have to do, there's 8 total problems. You have to do 4 because I did 4 of them in my slides.
Okay.
Okay. Now I have a new question for you. I'm going to give you a question and I want you to think about it and I want you to do it visually. And this is a great problem that's always on the final exam, just so you know. So you might want to write that down, right? Pay attention. Okay, so it says use a diagram to solve an application of fraction problems. A dress is on sale for 1/3 off the original price. 1/3 off the original price. The sale price is $48. What was the original price? So think about it for a few minutes. Don't use decimals in any way. Draw a picture. And I'm going to give you about 3 minutes in here together. And then I'm going to put you in your breakout room so you can discuss it. Okay. So you have about 3 minutes in here. So make sure you at least get the info from the problem. Okay, I'm going to put you in your breakout rooms. Alyssa, do you already have an answer? I don't know. Your face is confusing me. Okay, your face is like, I don't know if you were like, this is so easy or this is so
Definitely.
hard. Okay. All right, so I hope your teammates can help you. Okay? Call me in if you need help, but really draw a picture. Hello, hello, you're back. Okay, now each team has a person that they've designated the person that's going to explain and share. Yes? Okay, so we're going to start. I only visited one team, so we'll just start with that team. So it was Bree, Karen, Jessica, and Evelyn. You go first.
Okay, it's me. So the sale price is $48 and that is 1/3 off. So we did blocks of 3 because 1/3 is $48 and to make it 3 out of 3 a full price. And so that full price would be $144.
All right, so that's that team's answer. Thank you, Evelyn. All right, let's go to another team. Let's go to Alyssa, Essay, Karen, no, sorry, Karina. I don't know what's happening to my reading. And Sydney, who's your person?
We didn't really decide, but I'll just go for my team.
Okay. Do you have a picture?
I did not draw a picture because I was confused on the problem, but now that I've figured it out, I know how to draw a picture. Because in my
You're
brain, I
defeating the
know.
purpose. Remember, we want to draw the picture first, but that's okay. Go ahead.
I didn't know how to incorporate. I was like, do I draw 4? Yeah, I was just overthinking it too much. So we decided that we did 48 over 1 divided by 1/3. And then we tried that thing you said not to do. And we cross multiplied. And then we got 144 over 3. So then we had decided that each 1/3 was $48. So I originally thought that it was going to be 96 because a 1/3 was off, but then the 144 makes more sense because it's the whole item. Does that make sense?
If it makes sense to you, that's where we'll start. So is your answer 144?
Yes.
Okay. Let's go to Hannah, Betty, Brianna, and Vanessa.
So I'm gonna be talking. I did the exact same thing what Alyssa did. I forgot the original price part.
Okay. What's your answer?
It would be 144.
Okay. All right. So you just did the mathematics. You didn't draw a picture?
I did. I drew a number line, but I only did from 0 to 48.
Okay.
Yeah, I think we all did that. I did the same. Well, I did the same thing Brianna did in my group. So
Okay. All right. Let's go to Tristan. Yeah, let's go to Tristan, Amanda, Michaela, and Sarah.
We didn't decide, so I'll just talk. So I don't know if you'll be able to see this at all.
Yep.
Maybe. Okay, so I drew the hole and then split it up into thirds. And then I took a third off so that you know that 2/3 is 48 because that's the sale price with 1/3 off. And then knowing 48 is 2/3, I split that into half to get what 1/3 would be, which was 24. And then to get the original price, I just added another 24 to fill in that last third, and I got 72.
Okay, so your original price is $72.
Yeah.
Okay. Let's go to Madison, McKenna, Bethel, and Sunita.
So I did the same as Tristan. I broke mine down into thirds, and then I did since the sale price was 48, I divided it by 2, so I knew that each 1/3 would be 24. And then I went down the bottom. I marked one off, so I needed the sale price of the 2 boxes. So at the end, I did 24 times 3. It gave me the price of 72 as my original price.
All right. 72 what?
$72.
Okay, so dollar signs are helpful, right? So make sure you do that. Okay, last group, Hannah, Tyler, Elena, and Kelsey.
All right, I'll be presenting for our group here. I did the same thing as Tristan and Sunita. Sorry, we took the, and I apologize, it's very small. We took 2/3 was $48, and then what I looked at it was is I'm looking for 1/2 of the 2/3 to find each individual 1/3 of the original cost, and then once I found that, you add all 3 of the thirds together to get $72 as the original price of the dress.
All right. So we've seen 6 groups. 3 groups had one answer of $144. 3 groups had one answer of $72. Which one is correct and how do you know? I want you to think about it, and you might remember the people's names. I don't know. It doesn't matter. Get your answer ready in the chat. Which answer is correct and why? Which answer is correct and why? So, or maybe there's another option. I don't know. Maybe you have another answer. So our 2 answers that we had were $72 and $144. So get your answer ready in the chat. Which one is correct and why? And it might take a couple minutes because you might be processing again, right? So don't hit enter yet. Okay. I'm so sad because I didn't record you guys presenting. I had paused it when you guys were in breakout room, so it wasn't this big void of nothing. And then I missed all of your presentations. I mean, I didn't miss them because I saw them, but we can't watch them again. So we still have a discrepancy. Is the answer 144 or is the answer 72? Tyler, what's happening?
I think after reading through everyone's descriptions and what they kind of see, I see where there is an issue. At least I'm hoping I see it. A lot of people are seeing that the dress is on sale for 1/3 of the original price at $48 and not 1/3 off of the original price, meaning that the $48 to them is 1/3 of the full price of the dress, whereas the $48 is actually 2/3 of the original price of the dress.
Any of you who got 144, do you hear what Tyler is saying? Is that maybe the misunderstanding that occurred?
McKenna also said it really well in the chat, I think, so that might help.
Who did?
McKenna.
McKenna. Okay, sorry, I just didn't hear who you said. Let's read what McKenna wrote. $72 is correct because only 1/3 is taken off of the original price. We still have to pay 2/3 of the original price. If each copy of 1/3 is equal to $24, then 2/3 of the original price would be $48, and $24 or 1/3 of the original price is discounted. Okay, so 1F was the difference. Off versus of. Yes? Off versus of. Alyssa's like, are you kidding me right now? I love that face. That is the best, right? She's like, are you kidding me right now? So if we don't read very carefully, we can easily get the wrong answer, okay? Because if I said $48 was 1/3 of the original price, then I would take my rectangle, split it in 3 pieces, and put $48 in each of the 3 pieces. Yeah. So you guys who were doing an interesting, by the way, here's a picture. So what I want all of you to do that did this, whether you made a mistake on it or not, make sure you're making yourself notes. So this is the sale price. This is the discount. And the original price, somebody had it really nicely labeled right here. This is the original price. Try to label as much as you can in your diagrams. It's very helpful, okay? And be careful that you don't write things that are not mathematically true, right? So I saw this. What's wrong with that? What's wrong with this right here?
It doesn't equal 1/3.
Yeah. Now, do we understand what the person was trying to say?
Yeah.
Probably, right? At $48 is 1/3 of the price. But without those labels, we're sending a very, very bad math message, right? We're saying that on a number line from 0 to 1, here's 1/3, which is also 48. Somehow I'm not sure that's the message you meant to send, right? So be careful. If you're wondering why students get confused, sometimes it's us that do it, okay? Unintentionally, just by not practicing MP6 attending to precision. So, by the way, I'm a little confused at what some of you were doing because, and you said, I did the same thing as another group. You said, okay, I did 144. Okay, some group said 48 over 1 divided by 1/3. Yeah? But then that same group said they got 144 over 3. Now be careful, because if you're trying to apply the strategy we were just talking about, you can't mix them up, right? The strategy we were just talking about, you would multiply, you would cross multiply. So 48 times 3 is 144, but the denominator would be 1, yes? Which is how you got your answer of 144. But if you write 144 over 3, do you see how that's just 48? You're just undoing what you just tried to do. Yeah, so be very careful. Stay away from blank math equations that are not sensible. Go here into a picture. If it says it's split into thirds, I guarantee you all of you can draw a picture split into thirds. I know you can. You know, you totally can. All right, so that was fun, wasn't it? I love drawing pictures and solving problems with pictures. I have such a fun one I used to give people. Do you remember problems where it was like the salary this year is $35,000 a year, but they got a raise from their last year's salary of 5%. What was the salary last year? You remember those problems? You know, you can do them all with pictures. Yeah, you can. No algebra needed. You can use algebra, I'm just saying, but you can do it way before you can do algebra. Okay, so we didn't touch proportional reasoning because I thought this was really important. I haven't let you guys teach enough and explain things enough, and it's really good for us, even if we make a mistake. I'd much rather you make a mistake right now than in our final, right? So if you made a mistake today, don't worry about it. I hope you learned something. That was the whole goal. So I'm not even sure what your exit ticket is, and it might be proportional reasoning. So if it is, we'll just skip it. Actually, we'll just skip it because it's time to go. So make sure you do your proportional reasoning assignments, and we'll pick up there tomorrow. Okay? stay on here if you have any questions for me. Otherwise, don't forget to do your flip grid and your other assignments that are due on Wednesday. I'll see you tomorrow. Bye.
Thank you.
Yep. See ya.
Roxanne,
Yes.
is there a way, or is it not allowed, if we have one of the more reviews like we did for the other midterm? Like where it was just optional to do? Because some of the bullet points that are on there for the end, I know what they mean, but essentially like as an example for it, it would be nice to have like a visual so that I knew what I was trying to accomplish.
I'm pulling it up right now to see if I have a more, I do have a more practice final exam, and it's not published. I don't know why. Now it is.
Perfect.
So now it's up.
Thank you.
Yeah, and let me know if you have any questions. Like if there's a bullet point that you don't understand on the final exam, whatever outline thing, just ask and I can give you an example too.
Okay, cool. I'm going to go through that now. I already started it, so I'll see you tonight.
Yay.
I had a question. So the multiplying fraction pattern blocks, I don't know where mine's went. I think I've been trying to look for it this whole time. That's due tonight, right?
Yep.
Okay, so I will redo this because I don't know.
And that's the one that if you go to the multiplying fraction slides, you'll see the 4 examples already done for you.
Okay.
And it's the first 2 on the front and the first 2 on the back.
Okay.
McKenna.
So I was working on the more fraction operations. I actually started it last week because it was like in that module, so I thought it was due. But when I got to question 5, the question, it was 48 over 12, and then there's like 2 boxes for a numerator and denominator. And it's just asking to simplify it with the prime factorization. So I put 7 over 2. But it keeps marking me wrong, and there's a few others that are like that. I don't know if like we just haven't gotten to that yet, and there's something.
No, let me look because I think it wants you to write out the prime factorization, but I'm going to pull that up right now.
Okay.
Let me pull that up.
Yeah, it does. It wants you to write out like everything, like 2 times 2 times 3 times something. Because I did the wrong more this week. I did next week's. Is it the one that has like 44 questions?
Yeah, that's what I was doing
Yeah,
too.
I did that the other day, and I thought it was due the other day, but when I was finished, I was like, wait, no. It's next
So I just gave you guys 2 weeks for that one because we did fraction operations in 2 weeks instead of 1 week. So what number was that?
That one was 5.
Okay, so number 5. So I pulled mine up so we can see it. Okay. So it says write the fraction. Oh, let me share my screen. Hold on. It says write the fraction using the prime factorizations of the numerator and denominator. So right there, it told you what to do.
Are you sharing your screen?
Not yet, but do you see what I'm saying? When it said the directions say, here we go. Write the fraction using the prime factorizations of the numerator and denominator. Then write your answer in simplified form. Do you see that? So for prime factorization of 50, 50 is 5 times 10. 10 breaks down into 2 times 5. So we could say 2 times, I don't know why it brought up that menu. That's a weird menu for it to bring up. I don't know why it didn't give me just regular. That's weird. That's a weird menu. I haven't seen that menu before. Because I think it'll just let you do 2 times 5 times, I'm just using the asterisk as a 5. And then in my denominator, 2 times 5. And then it wants you to see that that will simplify to 5.
Okay. That problem
so
was
that's
a
what
little
it was.
different for my number 5 for some reason.
I can pull up yours. Hold on. It'll just take a minute. Especially because I'm in the wrong class. I wonder if I can do it in Canvas. I bet I can't. So I'll just pull it up in here. Hold on, let me stop sharing so I don't show everybody's grades for everything. So that would be bad. And I'll pull up your number 5. And that is fraction operations. Okay. Number 5. Was I still sharing my screen? No, I was. Sorry, I thought I stopped sharing. Okay, so right here, I can just show you what it wanted you to do. So you just put 7/2. You need to find the prime factorization of 42. So the prime factorization of 42, we would break down like, you know, just normal with factor trees. 2 times 21, 3 times 7. So we would write in the numerator right there, 2 times 3 times 7. And in the denominator, we would have factored 12 into 2 times 6 and 2 times 3. So we would say 2 times 2 times 3. That's what we would write in that middle box. Okay, then when we simplify, we would get 7/2. So if you look, I can show you the right answers. You see it wants 2 times 3 times 7 in the numerator, 2 times 2 times 3 in the denominator, and then it wants 7/2 for the answer.
Okay. The last box, it like where it says write it as a whole number, that's what I was looking at. And so I'm like 7/2, like I don't think that's going to be
So
a
you
whole number. So, okay.
So you have to read all the words that are there. So it says if your answer has a denominator of 1, write it as a whole number. So because it just didn't want you, like on my problem, how I got 5, it didn't want you to write 5/1.
Okay, that makes sense.
Okay.
And then while you have it pulled up, there was one more that was kind of weird. Let me see. I took a picture of it. Okay. Shoot, I don't know what question it is, but it's like the adding fractions one, and there's like all the steps of what to do.
I'll just scroll through here and see if you see it.
That one was kind of weird too with those blocks. I feel like it's towards the end.
This one.
Yeah, right there, right there.
Okay. So factor the denominators, use prime numbers only. So it wants you to go 3 in the numerator, and then it wants you to go 2 times 2 in the denominator. And then 5 in the numerator, and then 2 times 2 times 3, right? Because that's 12. And then it says write equivalent fractions with the LCD, use prime numbers only. So basically it just wants to show you, well, my LCD must be 2 times 2 times 3, which is 12. So simplify, leave the denominators in factored form. So 2 times 2 times, 2 times 3. And this would be 2 times 2 times 3. And then my numerator here, I had to add a 3 to it. So I did 3 times 3. And over here, I had to add nothing to it. So I'm just going to put a 5 there. So now it says simplify your numerators. So that would be 9. That's 5 still. And then I'm going to write 2 times 2 times 3 still. And 2 times 2 times 3 still. Combine their numerators. So 4. It didn't say anything about my denominator yet. So 2 times 2 times 3. We'll see if this is right. And then it wants you to factor the numerator. And then leave the denominator factored. Now it wants you to simplify. So that's going to be 1/3.
Wow, I've never seen a problem like break it down that many steps. I got like the 1/3 answer and stuff, and I knew where the 9 and then the 4 was before that. But yeah, I just wasn't too sure with the factorization part.
Yeah, so let's see, make sure we wrote everything correctly. Because we can see this 3, 3, yep, 5. 9, 5. 2 times 2 times 3, 2 times 2 times 3, 4, 2 times 2 times 3, and 1/3. There you go. So yeah, so if you just follow every single one of these steps exactly, you'll see it. Because this is like the long way home,
Okay.
right?
Thank you.
Yeah,
That makes
no
sense
worries.
now.
Yeah,
I do
thank
have
goodness
one
there's
more.
not 10 of those, right?
Right. I do have one more question, but if Kelsey needs to ask you first, she can totally go ahead.
No, I'm just watching. I'm just observing.
Okay. Okay, so on the more homework, it was one that you were just scrolling past as well. I don't know if you still have it up or not.
Yeah, I do.
Okay.
You're
It
good.
was the one where it's like, for example, say it was like 1/2 times 6/10 or something, and then it wants you to show it in the what's it called? Like the little blocks, almost like a
Like this
yeah,
one?
right there. Yeah, I don't
Okay.
understand that.
So if we think of your copies of, so 8 times 1/12 means what?
So 8 copies of 1/12?
8 copies of 1/12. So you're looking for a picture that's showing 8 of something,
Mm-hmm.
right? And then, so you can eliminate some of them. Like there's no way it can be this first one.
Mm-hmm.
It might be the second one because there's 8. It might be this third one because there's 8. But there's no way it can be these 2 or these 6.
Mm-hmm.
So now I
Okay.
just have to pick and say, okay, is this showing 8 copies of 1/12? Well, no, it's showing 8 copies of 1/6. So it can't be this one. So it is this one.
Okay. Yeah, there was another one kind of similar to it too, but there was only one cube. I
Like
think
this
it
one?
might have been, yeah, it was that. That one's really weird to me because I don't know if it's looking for the answer or if or is it also trying to just model the 2/5 and 6/10.
So this is similar to like the area model or the array model. So you want to see, so on one of these, either vertically or horizontally, it's going to be showing 2/5, and then the other one is going to be showing 6/10. So you'll want to look, so like this is showing 3/5 horizontally, right? Because these 3/5 are shaded. This one's showing 4/5. This one's showing 3 somethings. I don't know, 3 something. So this one is showing 2/5. So now I need to look vertical, and I say, okay, so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. They all have 10s in them, it looks like. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Yeah, so I want to see where 6 of them are shaded. So I want to know, I want to see where there's 2 shaded horizontally and there's 6 shaded vertically. So
Okay,
it would be
so
this bottom right one.
there's only one answer for this one?
Yeah.
Okay, I think I was also wondering like if we had to find one model that showed the 2/5 and then like another one was the 6/10 or something. I didn't know if it was just one block, if that makes sense.
Yeah, and
But,
this is
okay.
from the day, this is from your fraction Jamboard from Monday. So if
Okay.
you look at that fraction Jamboard where we switched our numerators and denominators, it's on those slides. So basically what this is showing is this is showing 2/5 on this horizontal because I have 2 rows out of 5 shaded.
Oh,
And
okay.
then it's showing, if I change colors, it will help. Then vertically, it's showing 6/10 because I have 6 of these shaded.
Okay.
And then this right here is my solution. The overlap is my solution, which would be
Oh,
1,
okay.
2, 3, 4, 5, 6, right? 6.
Mhm.
And then what do we have? 2. So 1, 2, 3, 4, 5, 6. So that's 12 out of a total of, what the heck? I can't even see with all my colors on there. Can you?
Barely.
It's so much better when I write with my iPad. It's so much better when I write with my iPad. Because then, well, it's actually better when I'm in OneNote because then I can really tell. So 2/5 times 6/10. Well, I'm going to get a total of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. I'm going to get 12 for my numerator. And then total in this box are 50. So I'm going to get 12 over 50, and then I'm going to simplify. So this is the model that fits.
Okay. Yeah, when in doubt, draw it out. That's what I tell Maddie.
You're correct. Yep, I agree. I agree.
Okay, well, thank you so much. I appreciate you going over that. That's had me stuck for like a week now.
Oh, never ever get stuck for a week. Just click on that Ask My Instructor button, and I'll
I
send you an
can't
email.
find it. I can't find it. I always look for it, and it like doesn't show up on mine, or I'm just looking in the wrong
Okay,
spot.
I'm gonna look and make sure because I need to make sure that's enabled. I will check that right now. Thank you for saying that, because when people don't tell me, I don't know it's not there. You know, because there's only about 8,000 settings, and if I miss one of them, then I can't, you know, I can't figure out where it went.
Right.
So let me see if I can put that on there.
Okay.
Yeah, it should be on there, but you know how that goes. So help and hints. Okay. Okay, I just put it on there. So hopefully now when you see it, if you reload an assignment, like whenever, go back out, go back in, hopefully now you'll be able to see it.
Is it just like a little chat to you or something?
It's just at the top. Let me see if I can find it. Are you in more right now?
No, I'll go to it right now.
Okay, yeah, just go to an assignment and then share your screen and we'll look, because it should be very intuitive where it is.
Okay, so this is where my more is.
Okay, so go to a problem because there's no problem. Go to the next question. There you go.
Oh, I saw the message instructor right there.
Yeah. And
okay.
There you go.
Okay, cool. Yeah, that wasn't there before. So.
Click on that right now. Click on it right now, just so you can see. And so do you see how it puts the question in there for me?
Okay.
So, and then you can type at the top, I've worked on this 17 times. I don't understand what this question is asking me. And then I can answer. So I'm so sorry that wasn't there. I can't believe no one told me that.
Maybe
you saw how fast I changed it, right?
Yeah.
Okay. Oh, I'm glad to see on your screen that I want you to update Google Chrome, because mine has been doing that like constantly and it's so annoying.
Yeah, I get that every day.
Okay, how are you feeling about fractions?
I think I'm doing okay. I feel like during like the live